Okay, so this graph here, if I was to take the first graph, x squared minus 4 over x minus 2, remember we want to factor and cancel. So this difference of squares in the numerator, so these cancel, so I get y equal x plus 2, but remember there's a hole where x minus 2 equals 0, so there's a hole at 2. So I'm going to have a line with y-intercept 2, and when x is 2, I'm going to have a hole. Do I know where that hole is? Yes, if I plug x equal 2 into here, I have the y value of 4. Okay, then what does this say? Oh my goodness, when x is 2, you plug it in, so it's just the nice line. Okay, let's try another one. So this is y equal x minus 3, x plus 3. Then, if I have x minus 3's, those cancel. So I have the line x plus 3, but there's going to be a hole at x equal 3. So I have the line x plus 3. There's the y-intercept. When x is 3, right? So when the x is 3, that's when I have a hole. And how do I find out where that hole is? Plug 3 into here, and that gives me the y value of 6. Okay, so when x is 3, it says make the y value 0. Okay, this looks very much like that graph, doesn't it? But let's check out a couple of numbers. We know we can't use 3, so let's just try some numbers on either side of 3. So what happens when I put in 4? I get 1 over negative 1. What happens when I plug in 5? I get 2 over negative 2. Oh, that's where I'm getting the negative 1. So 3 we know is the number we cannot use, but when I plug in 4 and 5, I'm getting the negative 1, so it looks something like this. And we could just double check. What happens when I plug in 0? If I plug in 0, I get 3 over 3, so that's 1. So up here, right, there is the y value of 1. And so then it says when x is 3, you fill it in at 2. Okay, average velocity. So average velocity is change in distance over change in time. So if this is the position function that's measured in feet, and t is in seconds, find the average velocity over this time interval. So s of 3, plugging in the t equal 3 into the s position tells you where it's at time 3. S of 1 tells you where it's at, its position at time 1. So I have 36 subtract 4 over the change in time, 3 minus 1. So that gives me 36 divided by 2, and it is in feet per second. Okay, let's try another one. Here's our position function, and we're asked to find the average velocity over this time interval. So it's going to be s of 4 subtract s of 2 all over 4 minus 2. So s of 4 means put 4 into here. So 4 cubed is 64 minus 1. Subtract, now I'm going to put 2 in, so I get 8 minus 1 all over 2. So here I have 64 minus 1 minus 8 plus 1. So I have 64 minus 8, so that gives me 56 divided by 2. That is the average velocity, feet per second. All right, last little bit here. If I want to get rid of fractions within a fractions, I'm going to suggest always that you start by rewriting the terms as the fractions that they are. So this y to the negative 1 is here. It stays in the numerator. So I'm going to multiply by the least common denominator on top and on bottom, and cancel as you go. So I'm multiplying 1 over y times xy, so I get x. If I multiply 1 over x times xy, I get y. And don't multiply the denominator out. And look at that. I get some canceling, so I get 1 over xy. They won't always turn out that great, but this one did. This one here, let's rewrite it. 1 over x squared plus 1 over x all over x cubed. So the common denominator from the top and the bottom would be squared. That's the least common denominator. So canceling as I go, I'd get 1 plus x over x to the 5th power, right? Because you add exponents, x to the 5th. Okay, so between these two fractions in the numerator, I see that x plus 1 times x minus 1 is the least common denominator. So I have to multiply top and bottom by that, right? So distributing, multiplying this term by this term gives me x minus 1. Multiplying this term by all of this, the x minus 1's cancel, so I have a minus x times x plus 1 all over x plus 1, and I have two of them, so squared times x minus 1. All right, anything happening in the numerator here? A little bit. So I have x minus 1 minus x squared minus x plus 1 squared, x minus 1. So the x's cancel. So I have minus 1 minus x squared, x plus 1 squared, x minus 1. Okay, so what if I had you do this? Find the difference quotient with 1 over x. So that means this first term will be 1 over x plus h minus 1 over x all over h. So the least common denominator would be x times x plus h, x times x plus h. So when I multiply this term times this, the x plus h's cancel, so I get x. Multiply this times this, the x's cancel, so be careful with that parenthesis. This negative has to go to both terms. Then I'd have h, x plus, oops, and I lost my x. Okay, so if I distribute that negative, x minus h, so I have, I'm going to pull this x and h together, x, h, x plus h. I see the x's go away, right? And then I got a negative h over xh, x plus h. The h's cancel, so I have negative 1 x plus h.